Good morning, everyone. The study that I wish to present to you today is a collaboration with the Photograph Conservation Studio of the city of Paris, in particular with Bruno Le Namouric and Stéphanie Le Damoiselle, as well as the Conservation Studio of the French National Archives under the direction of Bertrand Sainte-Marthe. In 2020, the Photograph Conservation Studio of the city of Paris noted that an albumin print framed and exposed for several months showed persistent deformation. This print was inlay mounted. This technique bridges over the print into a paper frame using Japanese paper strips with an adhesive. The inlaid print is then mounted in a window mat protected with a sheet of plexiglass on the front and another one on the back and sealed with pressure-sensitive tape. In this case, Filmoplast P was used instead of aluminum tape. This paper tape is more permeable to moisture, and it is probable that the diffusion of some moisture through the Filmoplast P was the cause of these strains. To understand these mechanical behaviors, a similar mounting was made on a 19th century albumin print and subjected to a progressive increase of relative humidity up to 90% and then back to 50% relative humidity. To follow the changes, we took series of pictures with two cameras to get 3D images during this experiment. And we applied digital image correlation techniques to those pictures to assess the in-plane and out-of-plane deformation of the albumin print. The software we used allows to calculate the hygroexpansion of the Japanese paper hinges and the hygroexpansion of the albumin print. We notice that the albumin print expands much more than the Japanese paper when the relative humidity increases. Those differences in behavior are the results of the drying methods that was applied during the manufacture of these papers, while the Western papers were left to dry freely hanging. Asian papers are traditionally dry on wooden or heated metal plate. This constrained drying method limits their hygroexpansion. So as a result, the increase in humidity in the frame expanded the albumin paper more than the Japanese paper hinges, especially in the cross direction. Due to the hysteresis phenomenon of the cellulosic fiber, those deformations are persistent when the humidity decreases. So it is necessary to carry out a flattening treatment after dismantling. Once again, these observations underline the role of the frame in protecting a print. In order to better quantify the impact of the different type of mounting on a photograph, we tested different materials and mounting techniques, and we monitored the temperature and humidity inside the frame as well as the mechanical behavior of the photograph. Different types of mountings were prepared. First, photographic print was framed in a window mat covered with glass and a sample backing mat board. So the wall was sealed with the Filmoplast PA90 tape. Second, the same set was prepared, but a marble seal sheet was added onto the back, which was sealed with Filmoplast PA90. Third, instead of the Filmoplast P90, we use a 3M aluminum pressure sensitive tape with a marble seal sheet on the back. And finally, a last frame was prepared by having the window mat between two glass plates without any taping on the edges. Paper clips were used instead to maintain the material. The cardboards were preconditioned in the room at around 40% relative humidity. We introduced data loggers to record temperature and humidity every hour during several months. Then the frames were left in my office, leaning against an outside wall during my stay at the Conservation Center in New York City from August to December 2022. I downloaded the data when I returned to France at the end of December 2022. Our laboratory was built in the 1970s with concrete without any thermal insulation. As you can see, the fluctuations are important, from 93 degrees Fahrenheit to 59 degrees Fahrenheit in a short period of time. The temperature inside the frames follows that of the room, whatever the mounting. Slight differences appear from November onward when the building's heating system is switched on. There are differences in temperature depending on the position of the frame in relation to the heater in the room. As expected, the type of ceiling and framing does not influence the temperature in the frame. During these few months, the humidity in the room varied from 23 to 80% relative humidity, depending on the outdoor conditions. The humidity in the frame without a vapor barrier on the back and taped with Filmoplast P90 very closely follows the humidity variations in the room. When we added a piece of marble seal on the back, the humidity variation in the frames are very slightly reduced. We observe similar behavior if the window mat is sandwiched between two pieces of glass held together by paper clips. In conclusion, the water vapor diffuses quickly throughout the back or the edges of the mounting if they are not protected. Thus, any external variation in relative humidity in the room very quickly alters the humidity inside the frame. The humidity inside the frame is well stabilized if the frame is tightly sealed with marble seal and an aluminum tape. A small periodic fluctuation of about plus or minus 1% relative humidity are due to temperature changes between days and night. When the temperature decreases, the hygroscopic materials, the cardboard, the glue, the paper in the frame absorb more water vapor, which they release when the temperature increases. So the photographic print also acts as a buffer for humidity, and our next step was to assess how the print deforms in a sealed frame when the temperature changes. We placed fiber-based photographs between two glass plates and sealed them with an aluminum tape. This set was heated with a flow of air. We then let the photographs return to room temperature. So we took digital pictures regularly, every 1 to 10 seconds, and we assess the dimensional variation of the print by digital image correlation. The green line in the graph represents the temperature variation, and the blue curve represents the expansion of the print in the cross direction of the paper. The red grid represents the 3D deformation of the sample over time. These measurements show that the size of the print increases when the temperature increases and then decreases when temperature decreases. There is a greater strain in the cross direction of the paper than in the machine direction. These experiments were reproduced with another fiber-based photograph and also with an albumin print. The strain is twice higher with albumin print than with baryta paper. So to sum up, these preliminary tests confirm once again the effectiveness of using a sealed frame to protect photographs in an uncontrolled thermohygrometric environment. We also measure a noticeable expansion of the print when the temperature increases. A print stored in a cold room can also shrink. However, the impact of temperature is much smaller than the impact of humidity. Our next test will study the strain of prints that are mounted and sealed in a frame at different relative humidity in order to follow the competition between the hygro expansion of the print due to the water vapor absorption and its shrinkage due to the lowering of temperature. Thank you for your attention, and I also thank Jérôme Politi and the Framing Workshop of the National Archive for their collaboration and the preparation of the material, the Photo Conservation Studio of the City of Paris, as well as the DMAP for their support in the acquisition of the 3D DIC equipment.